This question wants us to differentiate with respect to x log base 2 of secant of x plus tangent x. So finally we have a bit of a real challenge here, because we've got a logarithm that isn't base e, and we've got to use the chain rule to evaluate what we see on the inside of this, which means we're going to have to call upon our knowledge on how to differentiate trigonometric functions. Okay, so how are we going to do this? Well, first thing we're going to do, I know there's a formula for differentiate. Well, first thing always, let y equal to log base 2 secant x plus tangent x. Now, there's a formula for this to differentiate logarithms not of base e, but I inevitably forget it. So instead, what am I going to write? I'm going to write this as, I'm going to use my change of base, right? Do you remember what the change of base formula is? If I have a logarithm, log base a of b, I haven't written this very neatly, sorry guys. Let's try that again. If I have a logarithm, log base a of b, I can change the base. I can make this log base c of b over log base c of a. And this is why there's only two logarithm buttons on your calculators, the common logarithm and the natural logarithm, because really, using this change of base formula, you can get whichever base you want in the logarithm. So, I'm just going to change the base. I want base e, that's my natural logarithm, so I get ln of the same stuff up the top, secant x plus tangent x, and then I divide by the natural logarithm of my old base, which is 2. And I don't have to worry about this part too much, because this is just a constant. It doesn't matter when it comes to differentiating. It's just going to be constant because it's multiplied. So when I differentiate dy by dx, what do I get? Well, let's keep my ln 2 at the front, and then I differentiate this whole mess. So I start with 1 over secant x plus tangent x, and then I multiply that expression. So if I differentiate sec, I should get sec x tan x, which is in my MF15. And then when I differentiate tangent, I get sec squared of x. So, if we look at this, yes, we can see that there's certain something in common here. We can pull out this factor of secant x, so anyway, let's keep it 1 over ln 2 times secant of x, bracket, and then I've got tan x plus sec x, or tangent x plus secant x, and that's all divided by, what would you know, secant x plus tangent x. So as it turns out, this and this will cancel nicely for me, leaving me with secant x over ln 2. Now, some people are a little bit fussy. They don't like a ln 2 in the denominator if they can avoid it, and that's fair enough. So again, we're just going to change this back, and we're going to change this to base 2 now. So I get log base 2 of my former base, e times secant of x. And we are finished.